So first, a little preemptive. I feel like this. So it's always the case, at least the last 2 years, that at this point people start getting a little scared and freaking out, and I get people going to the counselor saying, "I got to drop calculus." So here's the deal on that. It's a little late at this point to go to stat because you've missed units. Also, I feel like a waiter, and you came to me, you ordered a steak, okay, and I brought you a steak, and then you look at me like, what's this? This isn't right. This is calculus. You asked for calculus. I'm giving you calculus. It's going to be hard. What did you think was going to happen when you signed up for calculus? You didn't sign up for, whatever, Alphabet 101. This is calculus. It sounds by nature pretty smart. It's going to be hard. In terms of what you're going to be looking at, if that's you, if you're thinking about it, then know this. First of all, AP Stats no longer an option. It's too late. Second, if you have holes, you're going to Calc Honors, not anywhere else. Calc Honors. And last but not least, if I haven't seen you in for help, I won't let you go anywhere. Okay? If you haven't been coming in for help, I'm not going to believe you can't do it because you haven't been doing everything you're supposed to do. Towards that end, because you're seniors, let me mention this one more thing. Okay? If you can't get help now, you have zero chance next year as a college student because this year, I'm in the building, you're in the building, I'm here before school, 7th grade, after school, I'm available probably 3-4 hours a day. Next year, you're going to be in your jammies in your dorm when you say, man, I need math help. So it's up to you to get out of your jammies, go across campus on your bike for 20 minutes, and hope that your professor's actually there for the 2 hours a week he has office hours. And that when you come in, he's happy to see you rather than saying, oh man, I need to work on my research and there's this knucklehead from Calc 1. This is as easy to get help as you can get. Next year, it's going to be really hard to get help. And so you need to learn how to do that. And I'll say this, I was good at math. And I had, in your shoes at this point, I had a D. Okay? So if you're thinking, I'm going to do it, I thought the same thing. I thought, man, I have no freaking idea what the heck is going on. And I had never, not once, asked for math help, ever. Okay, it was humiliating. And to me, that was humiliating. I'm good at math. I don't ask for math help. And eventually, my mom kicked me. So you're going in. I don't care if you don't like me. You're going in. And just talking to her, those things that I was afraid to say in class because it felt like everybody else got it. I said, well, I thought you did this. Oh, no. All of a sudden, she started to see what I was confused about, and it was pretty easy to clear up on 101. But it's hard to do that in a classroom setting sometimes. And so my point is this. I will match your effort. If you kill yourself, I'll kill myself for you, okay? I will come in before school, after school, whatever it takes to get you help, all right? But it's your education at the end of the day. It starts with you. You're the one, either way, I'm going to have a job next year, okay? You're the one that's going to have college credit next year and just save your parents $1,500 by doing loans. All right, it's got to start with you. So anyway, that's my plug. Please, if you're confused, get help. You have a test Friday. It'll be through everything you learned last week. And so if you don't say, oh, last week I did tangent. I don't know how to do a tangent. Well, come in for help and we'll overview you. Differentials. I don't know how to do differentials. Maybe I should ask about differentials. Come in and we'll practice differentials. All right? So be looking at the notes from last week and before, and if there's something you're weak on, you have 4 7 periods before school, after school. You have at least 12 options of time to get help. So please do that, all right? And I'm your biggest fan. I want you to do well. I don't want to give you a test that you're going to bomb. I want to give you a test that covers the material and you show you know the material. All right? So that's my little speech. What a way to spend a Monday morning, huh? Getting speechified by some math teacher. Here's the deal. I want to eventually build up to be able to graph a perfect secant cosecant graph, just beautiful. But to get there, I feel like I need to build you up a little and brush up on some sine cosine graphing skills before we get to secant cosecant. So we're going to gradually build up so that at the end of that page, you're going to be graphing those secant cosecant graphs really well. The first thing I want you to be able to do is find what a normal one period looks like of a sine wave. And I don't just mean one wave, the start and the end point. I mean the half point and the quarter points too. So this is the process I'd like you to go through, and it might seem a little long at the start, but it'll go really quick once you get good at it. So check this out. Say we did this one together. I first expect you to be able to find the period of a wave. You do that by taking 2 pi over the coefficient. So in this case, the wavelength is 2 pi over 2, which is pi. All right? I would then like you to, number 2, sketch the shape of the curve. This is a positive sine wave. There really are 4 shapes I need you to know. Positive sine, negative sine. Positive cosine, negative cosine. What's positive sine? Starts at the center and goes up. Beautiful. All right? Now, I want you to find a full wave, then half it to get a half, right? Half of pi is pi over 2, and then half that to get a quarter wave. Half of pi over 2 is pi over 4, yeah? Now you can then get the 3/4 point by just counting. 1 pi over 4, 2 pi over 4, which obviously reduces, to 3 pi over 4. And then you have all 4 key points that Mr. Rickman wants, and it allows you to find a scale that would be. In that case, I might use a pi over 4 scale, so those points can be found. Whether it's 1 box or 2, we'll talk about it. Are you with me on what I'm doing? Okay, so find the period, sketch the shape, find the half and quarter points, and call it good. So do those other 3 on your own if you're not quite sure what I did there, because I mumbled or because I didn't make myself clear. Let me know. And I'll come around and mumble on a more personal level. Homework coming around. I chose probably about 6 to 8 problems to look at. So if you have checks, that usually means fine. I'm just, yeah, it's good, it's good. But if you have an X, that probably means you did not have the right idea there, and that's a good warning to you. You might look at that. All right. Sure. So for the second one, did you get quarter points of 0, pi, 2 pi, 3 pi, 4 pi? Yes? Okay. For the third one, did you get 0, 3 pi over 4? I guess the next one would be 6 pi over 4, but reduced to 3 pi over 2. 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. For unreduced is fine, or reduced is fine, obviously. The last one, the pi drops out. When you have a pi in the coefficient, you actually cause the pi to drop out of the period, giving you a whole number for the period of 8, which would mean a half is 4 and a quarter is 2, 2, 4, 6, 8. And then we're good. Yes? How'd those go? All right. Now let's build. These then will involve finding the period, finding the quarter points, but then shifting them because they've all been shifted in some fashion. We'll do two of these together. Let's say this first one. What's the period? 2 pi. The wave looks like that. That's positive sign. If a full wave is 2 pi, then a half wave is pi, and a quarter wave is pi over 2. Pi over 2. I said pi over 4. I have no idea why. Pi over 2, 2 pi, sorry. Pi over 2, 2 pi over 2. 3 pi over 2, 2 pi. But this is then going to be shifted. Now I'm just going to focus on a couple of these. Let's just say, what will the first 2 be? Is this pi over 4 going to shift it right or left? Right. So 0 then will become pi over 4. What about pi over 2? What will it be? 3 pi over 4. You'll start to see a trend. It looks like odds. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9 pi over 4. Okay? Now that one was fairly clean. So let's say we look at the one below it. All right? First, find the period. And the period for that is 2 pi over 4 thirds. That's 2 pi over 3 fourths is reciprocal. So I'm getting something like 3 pi over 2. Do you concur? Okay. The shape of a negative sine curve is center line going down. 3 pi over 2. What's a half wave? 3 pi over 4, half that, and then half that again. So a quarter wave is 3 pi over 8. All right. So if I were to find the 3/4 point, 3 pi over 8, 6 pi over 8, this would be 9 pi over 8. If I counted by what a quarter wave, each quarter wave is 3 pi over 8. So you count up to the 3/4 wave by just counting 3 pi over 8, 6 pi over 8, 9 pi over 8. This one shifted 3 pi over 2. Well, what do you notice there? 3 pi over 2 is kind of funny in that it is a full period. And so this would actually shift right onto itself and shift one whole wavelength over, and it would be right back to where it started. Yeah? All right. Try the other 2 on your own, and let's see how they go. If you're not quite sure, let me know. check with me about what you got. Make sure that we agree. I guess that upper right one was probably the hardest for me. Do you agree with pi over 2, 2 pi over 2, 3 pi over 4, excuse me, pi, 5 pi over 4, 6 pi over 2, 3 pi over 2? Okay. For the next one, the period was 24, which makes for nice numbers. Half period would be 12 and quarter is 6, and then if you subtract 1, negative 1, 5, 11, 17, and 22. How we do? Okay. Now let's graph. You're going to see some similarities to the ones we just did above this here, and that was intentional. I didn't want you to start all the way from scratch. When you go to graph 3 cosecant, we're first going to graph its reciprocal 3 sine of x minus pi over 4. Now, that's going to look like the wave we just did right above it. 3 sine of x minus pi over 4. We're going to then work to the reciprocal. Now, I'm not going to graph the full sine wave because that's not the question. I'm just going to use it as a guideline. Here's what I mean. Let's start with the vertical part. What is the effect of the 3? A shift or a stretch? I heard amplitude. That's beautiful. All right, stretch. Let's go by ones. And so this will be centered at 0, but it's going to be stretched from negative 3 to 3 instead of negative 1 to 1. It's going to be 3 times as tall. Yeah? Looking at the previous then for my horizontal scale, what kind of horizontal scale would be logical to see those marks? Pi over 4. We need pi over 4. Now, whether you go a box to pi over 4 or 2 boxes to pi over 4 is up to you. But pi over 4 is definitely one of the way you want to go. You want to go 1 box to pi over 4 or 2? 2. All right. It's up to you. But obviously, the wider the more spread out you're going to be, and that's fine with me. Say we go 2. Looking at my points, it was at the center line at pi over 4, and then at 3 pi over 4, it was at a peak. So, center line at pi over 4, 3 pi over 4 would be, here's 1 pi over 4, 2 pi over 4, 3 pi over 4. According to my scale then, I would have a peak over there. Yeah? The minute I've done 2 points, I can just say count boxes. It seems like every 1, 2, 3, 4, I go to the next point in my wave. So I can go 1, 2, 3, 4. Where will I be at this next point? At the center line, at the max, or the min? At the far right side, I should be at the center. Going backwards, because you're expected to graph over the whole space, then you're going to go back 1, 2, 3, 4 and be at the max, min, or middle? Min. 1, 2, 3, 4, middle. 1, 2, 3, 4, max. Now, that's all I really want is those points. I don't want the whole wave because my graph looks busy and it makes it look like those are actually points on the cosecant curve, which they're not. Now we're ready for the reciprocal ideas. 1 over, our cosecant is 1 over sine, right? So if sine is 0, then 1 over 0 is a vertical asymptote. So wherever this crosses the center line, I'm going to have a vertical asymptote for cosecant. If I were to plug in pi over 4, I'd get cosecant of 0. Cosecant of 0 is 1 over sine of 0, which is 1 over 0. Uh-oh. So I should have asymptotes, vertical asymptotes, everywhere I have a center line dot. Okay? What's the reciprocal of 1? 1, all right? So anywhere where there is a max or a min, they're going to share those points. So I know that my cosecant will actually touch this point too. And then, now the sine curve normally does this, yeah? So wouldn't you say that as we get close to this point, sine wants to be small? Well, we're graphing the reciprocal. What's 1 over a small number? A big number. If you divide 1 by 100, you get 100. So when I graph the reciprocal, it's actually going to be an opposite relationship where this guy gets small, the opposite gets big.
they share the one pointer, the max, and then they head on out as they get closer and closer to where sign would normally be small. Notice that they don't come all the way into the axis, okay? I should not see this. There should be this region in the middle where the sine curve is. They should not be coming in below the max. They should be just touching the sine curve, right? So over here, you should see something like a min. The cosecant curve will come in, just barely kiss the sine curve, and then run away. And this, although it feels like you shouldn't even need to do anything because there's not a full wave here, you must do something. You should be graphing over the entire space provided, so graph over there. You follow? Try one more together, or you get the idea? Let you try it. Okay, I'll let you try. I will walk around, and if you have a clarification question, I'll be happy to answer. Make sure you see the connection to the ones above. Use your rough drafts above to help you decide the period and the scale. All right. Now, we might have something a little different based on your scale choice. But we can still check to see that you agree. First of all, on the second one going right, do you have a point at 0, 6? Yes? No? Okay, great. Do you have a vertical asymptote at pi over 4? Check that. Do you have a point at 2 pi over 4, negative 2? Or pi over 2, negative 2. Okay, do you have that point? If you have those points and the asymptotes, then you kept the pattern consistent, then you should be here. Okay? For this one, just a quick look, do you have a parabola to the left of the x-axis opening up and a parabola to the right of the x-axis opening down? Okay, and I scaled mine by half, so that's why I'm getting 2 boxes up to 1. Yes? No? All right, and then last but not least, check this guy. It should have some crazy asymptotes, but according to your scale, do you have something like the point negative 1, 6? If you do, then you're probably on the right track. Do you have an asymptote at 5, x equal 5, vertical asymptote? If so, then you're probably again on the right track. If not, then come in and we can practice it a little more. It does take some practice, and that's to be expected. All right, backside. Next idea is graphing tangent, cotangent with possible changes. So let's graph the basic, and then let's talk about changes. On the unit circle, would you tell me tangent at every pi over 4, starting at 0? Tangent of 0 is 0. Tangent of pi over 4 is 1. Tangent of pi over 2 is undefined. 3 pi over 4? Pi. 5 pi over 4? 1. 3 pi over 2? Undefined. And 7 pi over 4? Negative 1. Okay? Let's also do cotangent in red. Cotangent is cosine over sine, so it's going to be undefined at totally different places, wherever sine is 0. So what's cotangent at 0? Undefined. What tangent is 0, cotangent will be 1 over 0, so undefined. Reciprocal of 1 is 1, so cotangent's 1 there. When tangent is undefined, cotangent will be 0. Reciprocal is still negative 1, tangent 0, cotangent's undefined, 1, 0, negative 1. Yeah? So, when I go to graph these, or when I ask you to graph these, this is how I want it done. I obviously want the asymptotes clearly located, but I also want the 3 points per curve. Now, to me, it's important that you show what's going on at pi over 4, because that's how you're going to communicate you know what's stretched or not. If I don't see this point, then I can't see your vertical component being stretched correctly. If it's just about the center point, that doesn't really communicate a vertical stretch when it happens. So I've got to see those points. If you put your asymptotes down first, then you have asymptotes at pi over 2, which according to my scale would be there, and negative pi over 2. One clear wave then, and then we'll use the pattern. At 0, tangent is 0. And at pi over 4, tangent is 1. And at negative pi over 4, tangent is negative 1. I'm spacing mine by, or scaling mine vertically by half. After that, you really, again, you have 5 key points. Asymptote, lower point, middle, upper point, asymptote. So continuing on, after the next asymptote, 2 blocks over, I'll get another minimum, middle, upper. And my wave looks like that. So your tangent, and again, according to the way I scale this, I don't get a full tangent wave, but you still have to graph the points that are there. Going backwards, left of negative pi over 2, and you're going to have an upper point, a middle, or a mid. An upper point, 2 boxes to get an upper point, 2 boxes to get a middle, 2 boxes to get a lower point. And at that point, we run out of room, so we'll just do as much of the wave as we can graph. All right. So far, so good? Try cotangent on your own using the red for a key. Try using the same scale, pi over 4 to 2 boxes horizontally. How do we do? Does your graph have an asymptote right at the y-axis? And do your curves kind of bend the opposite way that tangents do? Yes? Okay. All right then. Seems like you should be good. Let's move along to then slight changes. We know tangent shape right above it, but what will the 1 do and what will the half do? What does the 1 do? Up 1. So we might be centered more at 1 unit up. And our key points then be more at 2 and 0. Okay? What about the over half? Is that stretch it horizontally, vertically, or squish it horizontally or vertically? Stretch. Normal period here is not 2 pi, it's pi. Pi divided by a half means this period will be 2 pi. So instead of my asymptotes being at pi over 2, they'll be at twice as wide pi. Yeah? Are you looking? Pi over 4, so I'm going to go all the way up 1.4 to pi. And I'm going to have an asymptote at pi and negative pi. Okay? 0 is still going to be at the axis, but now it's going to be shifted up 1. And instead of this quarter point being at pi over 4, it'll be at pi over 2. So I'm going to have a point at pi over 2, 2, and negative pi over 2, 0. And it'll be really stretched like that. And this will be this. It's up there, I don't even see those points. All right, do you follow? Try this bad boy on your own. Cotangent of x minus pi over 4. Your y-axis, is it crossing the y-axis at -1? If so, you might be on the right track. Do you have an asymptotic pi/4 and 5 pi/4 and -3 pi/4? If so, you're on the right track. Okay, last idea. This kind of goes with cosecant, but it's reciprocal graphing just generally, not necessarily reciprocal of trig, but reciprocal of anything. So let's start. I'll come back to these big ideas in a second, but let's start by getting this graph here. If I were to sketch x minus 2 squared times 3 minus x, is that shape positive x cubed or negative x cubed? It's negative x cubed. And negative x cubed looks like that, right? What are the zeros? When you have factored form, it allows you to find zeros. They are 2 and 3. I'm gonna, in order to spread this out a little, I'm gonna go by 2 boxes per one. So I'm gonna have zeros at 2 and 3. Right? And I know the shape on the far left is it's gonna go up, and on the shape on the far right is it's gonna go down. The hard part is the middle then. How do you make that middle point work? What's going to go on in the middle? And how could I, if I wasn't sure, how could I figure it out on my own without Mr. Rickman telling me? You can always, when you're graphing, the backup is always plug in points. So what do you, if you put 2.5 in, focusing on the sign mostly, if you put 2.5 in to see what's going on in the middle, what kind of sign do you get? Positive or negative? 2.5 minus 2 is positive. Squared is definitely positive. 3 minus 2.5 is positive. So it's positive. So what's going on at 2? It feels like it's not passing through. Instead of it's bouncing off that point, yeah? Why is that? Because of the square, okay? So what? There's a square. Why would it bounce off a square? Other than that's what I was told that happens. If you square negative, what do you get? If you square positive, what do you get? Okay, so there's no sign change. So you can see there's no sign change around the square. That's why around that term that's squared, it won't change sign. Even when it's a little below that positive, the square is making it come out positive, and when it's above, it's positive. Now this is to the first, and so it will change signs at 3, because the first power, that is different signs. So that makes sense. It actually should be a smoother curve. It makes it look like a cusp there, and that's, for those of you who are top honors, you know that's not good. But that's right. Now let's talk reciprocals. The idea of the day, or this topic now, is what happens when you graph a reciprocal. There are a couple big ideas. Let's start with this. When the graph of S has an x-intercept, then F, if it's at the x-axis, then F, or Y, must equal 0. Well, then 1 over F will be 1 over 0. And what does that mean graphically? A vertical asymptote. Wherever this has an x-intercept, the reciprocal will have a vertical asymptote. So I'll have a vertical asymptote at 2 and 3. All right? Second, what's the reciprocal of 2? 1/2. What's the reciprocal of negative 1/2? What's the reciprocal of negative 1/3? Negative 3. What I wanted you to notice is that the sign didn't change. When you take the reciprocal, the sign doesn't change. So, where the original graph of F is positive, and by positive I mean above the x-axis, then the reciprocal 1 over F is still positive. It doesn't change the sign. Positive, and therefore also above the x-axis. So in terms of where my graph will be, I know it'll be above the axis because that was above the axis, above the axis because that was above the axis, and then below. I know my graph is going to be here, here, and there. It must be. Reciprocal does not change that sign. All right? The other ideas then is, what about the numbers themselves? Where the graph of f is small, and by that I mean close to the x-axis. If f is small, then y is small. And if y is small, then that's a number that's not very far from the x-axis. Well, what happens when you take the reciprocal of a small number? 1 over 100 is 100. So where the graph of f is small, 1 over f is large. And so large-wise would actually be far from the x-axis. There's this opposite relationship. So think of it like this. I'm going to erase this stuff. Okay? This point, as it gets close, close, close to 2, I'm getting smaller and smaller numbers. And reciprocal of small would be big. By the same idea, where the graph of f is large, the reciprocal will be small. So what's going to happen here when this goes to infinity? 1 over infinity goes to 0. And so this will get small. As this gets big, this gets small. As this gets small, this gets big. In the next region between 2 and 3, again, positive. So I know I'm up here. What's the shape? Parabola, yeah. Small and small, big and big. And it would have to be something like that. And then negative, so negative. Where this is small, this will be large. And where this is large, the reciprocal will be small. Those are the big ideas. You follow? Okay. We're probably not going to get to questions on the fun sheet, much to my chagrin. I will put the key to the fun sheet online so you can at least see how you're doing. I encourage you to not just, okay, whatever, I'll just copy what he did, which will teach you absolutely nothing. Use what I did as a check, and if you're not sure where I'm coming from, then you should ask tomorrow. Don't assume that because you can copy down what I did, or because even what you can follow what I did, that means you can do it yourself. So please make sure you use it judiciously. Questions on 29. I'll give you a second to... Your performance on the test will be directly related to what kind of good questions you ask to fill in your holes and figure out your mistakes before them. Any questions on 29?
22.
22? Or did you say 2?
22.
22, yes.
What is the function do?
It was supposed to be due today, but we're not going to get the questions, so it'll be due tomorrow. How's that sound?
Thanks.
Okay, sure. Sorry if I didn't make that clear. Yes, ma'am.
3 and 14.
3 and 14? Okay.
10.
10. Ms. Rohrbaugh, by the way, you do a nice job of correcting your homework. I appreciate that. It looks exactly like I wanted. I should put it up as a model. I mean, she writes herself notes, hey, you did this wrong. I might use your homework as a key for how it should be done. Write yourself notes and say, hey, you did this wrong. In ink. That's actually not a bad way to study either. You go back to your homeworks and say, oh, there's red. Oh, yeah, I did that wrong. That's a good way to study. Yes?
We go over the assignment.
Yeah.
Answers.
You bet. Holly. I should have that for you. All right. Here we go. Number 22. Has that changed in any way? No. Okay. So, approximate the value for which I wasn't exactly sure what they were getting at when they say approximate. At the end of the day, I assume they meant use your calculator to, 3 decimal places.
Oh, okay.
That's what they meant by the directions. I think you should solve it analytically, and actually I prefer if you just leave it exact, natural log of whatever the answers are. If you did that, then you're fine. Okay? The directions aren't clear. Does that get you going?
Yeah.
Okay, cool. 3. 3 is, so you're finding, did I change this? Oh, shoot. So 3, darn it. I actually screwed up 3, I apologize. We didn't cover, last year I tried to do too much on differentials and it was disastrous. And then I changed how much I covered the first day. Fortunately, I didn't catch this before I gave you this homework, so you rightly should be asking about this. It's confusing. Rather than use differentials, just be able to use a tangent line. Now that said, I screwed this up, so if you leave it blank altogether, if you skip it, then that's fine. But in terms of preparing for the test, what you really should be able to do, which I intended to change this to, is to be able to use a tangent line test. Now that said, in terms of learning, do you want to go through how the process to that? Or no, you can do that, no problem.
I go over it.
Go over it? Sure. Okay, you bet. Great question. All right. So there's a process, there's really 2 skills. Be able to write a tangent line, and then also go a little further and be able to use a tangent line to estimate something, and that to me is obviously harder because you have to do it more. The first thing you need to do then is do the tangent line process and use to estimate that which they're asking about. The tangent line, let's first get clear in our mind what the function is. The function is the cube root function. You then choose a good, this should be a strictly no calculator exercise. And I had,
Good morning, Devlin students, faculty, and staff.
Oh.
At this time, please dismiss members of the Devlin Concert Choir to the landing outside of the library.
I forgot his name.
Today marks the 16th anniversary of the tragic terrorist attack of September 11, 2001, the deadliest terrorist attack in American history. Over 3,000 American lives were lost in New York, Pennsylvania, and Washington, D.C., including hundreds of police officers, firefighters, and first responders. Over 10,000 more people were injured. On September 11, 2001, President George W. Bush made the following poignant remarks. Terrorist attacks can shake the foundation of our biggest buildings, but they cannot touch